So we're going to look at C2 integration. You've seen integration already in C1. You know how to integrate x squared dx, that you increase the power and remember the plus c. But what we're going to look at in C2 is definite integration, which looks like this, the same, but there'll be a number here and a number here. So we're going to look at how you deal with having those numbers on there. So, first thing to point out is that your calculator will do this for you. Now, you can't just put the answer down, but it does mean that you can check it in an exam. So, what you need to do with your calculator is, first of all, press Option, and obviously the screen is going to change, unlike the static picture here. And then F4 is currently pointing at the word calc. So if you press F4, then you'll see that all of the options along here change, and then if you press F4 again, then it will have an integral dx sign. That will be above the F4. So if you press F4 to get the integral dx, then you can type in this function. So you can type in 3, just using the normal buttons, 3 plus 4, x is here, below alpha, you don't need to press anything else, this is x, this is the x button, 4x, and then cubed you get by going this up, and then 3 for cubed, and then minus, and for the 2 over x squared, just be careful, type in 2 divided by x squared, x up 2, or x squared, and maybe put brackets around that so that the calculator knows what you're doing. And then you use the comma button, so this is here, the comma, and you put a comma first, after you put the function, so you've got your integral 3 plus 4x cubed minus 2 divided by x squared, and then you put a comma, and then you put 4, which is this bottom number here, and then another comma, and then 6, which is this top one, and then you can press exe, and it will give you the answer. So that's going to be a way of checking that you've got the right answer, and but obviously we do need to know how to actually do it using your pen, so we'll show you that now. So, what I'll do is I'll use the calculator and work out the answer while we go through just the bit that you know how to do, which is the normal integration from C1.
Okay, so let's just have a look at the normal integration. So let's forget the 4 for a minute and forget the 6 for a minute. So we're integrating 3 plus 4x cubed minus 2 over x squared. So we need to get that into index form. We don't want the fraction there. So this is equivalent to 3 plus 4x cubed minus 2, and then the over x squared obviously becomes x to the minus 2 dx. Then we're going to, I want that bit, integrate. So we've got y equals 3, leave it down to, we've got x plus 4, wait to see, x minus 2, wait to see, x. Right, in this first case, we've got x to the north, so we want to become x to the 1, and we've got a 1 there. We've got 4x cubed, which becomes 4x to the 4. We'll flip that upside down. Then we've got 2x to the minus 2, which becomes x to the minus 1. Again, flip that.
So haven't you forgotten something really, really important?
Let's get into it.
We don't need it though, do we?
Well, if we're just looking at the integral,
yeah. Oh, yeah. Without
then
the
we
limit,
would do that.
then we need the plus C.
Yeah.
Yeah. We get this calculator out there.
We can.
Yeah. Yeah, the plus C is really important if there's no limits, but that's one of the things, isn't it, about this, that we don't need it.
No. So when we're just looking at it with no limits at all, we obviously need our plus C.
Yeah.
But now we've got our integration move, so we can look at it between the limits.
Yeah.
So this means where x is 4, right?
Yep.
And this is where x is 6.
Yep.
So we can put in 4 and 6 once we type this up, and we'll get a definite integral, which is why we don't need the plus C.
Yeah.
Right, so let's tie this up. So at the moment, y is 3x plus x to the 4 minus 2 over, minus is plus 2 over x.
Yeah.
Can we write like that?
Yeah, I like the big square brackets. This is really important actually. This isn't just something that's nice, this is proper mathematical notation, these brackets. So you need big square brackets and your limits are now on the right hand side to say I've integrated but I haven't put my limits in yet.
It's just helpful for you to keep track of also what you have and haven't done. So say if I were to go on to take the question, you've got a mess.
Yep.
Right. So what we're doing is we're imagining our curve, whatever it is, between 4 and 6.
Yep.
So, and if 6 represents anything that's below that, and then 4 represents anything below that, we're going to need to take the value 6 away from the value
Yes.
by 4. So, the integral is 6 and then that, and then, am I doing this right? I haven't done this in so long.
Yep.
2 over 6.
Yep. I would keep, yeah, exactly. I would keep these square brackets because what we're doing is we're first putting in the 6,
Yeah.
then we're going to subtract, and then we're going to put in the bottom limit, the 4. So if you keep, there's just so many minuses going to happen.
Particularly if you've got a minus.
Minus everything.
Yeah. 3, 4.
Yeah, so x is now becoming 4.
Yeah. 4.
Yeah, exactly. So it's up to here, this bit, this is just C1 all the way down to there. The only difference is you don't have to remember the plus C. And then
And you have to remember the limits.
the limits, yeah, they just kind of appear on the right hand side. And then this step is where the C2 happens. So you put the top limit in, x equals the top limit,
Yeah.
and then minus, and then x equals the bottom limit. And then from this point, it's just numbers really,
It's
isn't
just
it?
numbers, isn't it? So 3 6
Well, I say just numbers, but I've got a calculator. 3 times 6 plus 6 to the 4
I'll fill in anything that I can do.
2 divided by 6. Okay, apparently this first bit is 3943 over 3.
4, 3 over 3.
Yeah, and then this bit is 3 times 4 plus 4 to the 4 plus 2 over 4, which is 537 over 2. Okay, so if I do 3943 over 3 minus that other one, 537, then I get 6275 over 6, which is exactly, I should have written it up to prove it, but that's exactly what the calculator gave me, so I know I'm right. Hooray! Nothing's gone wrong, because the calculator gave me the same thing. Okay, let's try another one. I'll do this one. Do you want to try the calculator? Okay, so while we do the calculator jobby, trying to get the answer, I'm going to start off. Now this isn't ready to integrate yet because I haven't expanded the 2 root x plus 3 squared. This is all still C1 at this stage. Expanding out 4x plus 12 root x plus 9, I think. This is still C1. Now I'm going to integrate, so this will be, let's just do this. Big square brackets because I'm doing C2, not C1, so there's no plus C. So this was a 1, increasing to a 2, stick it upside down. This is a half here, that's the power of a half. Increase that to 3 over 2, turn it upside down. And this here is x to the 0, so increase that to a 1, turn it upside down. And what does this look like tidied up? 2x squared plus 24 over 3 is 8. X to the 3 over 2 plus 9x from 1 to 2.
Can I just scribble down, make a note somewhere of what
Yep.
I think the calculator is? Right, I measured that this is wrong, but I think
Yeah, will it do?
which is
do a nice fraction? Never mind.
Somewhere at 27 and just a smidge. Well, a smidge.
Okay, well let's see if we get the same. Okay, so I've done all the C1 bit. Now the kind of easier bit, in a sense, the C2 bit. So I'm going to put the 2 in first as x. So x is going to become 2. There we go. X became 2. And then minus, always minus. And then x can become 1. Okay. So, what have I got here? 4 times 2 is 8 plus, okay, I could do this exactly because what I've got there is the square root cubed, there. So if I take my 2 and square root it and then cube it, yeah, and then I've got 8 of those. Yeah. But probably that'll be why we've got a decimal coming out because of that. So that's all right, we can do decimals. Plus 18 minus, and then I've got 2 plus 8 plus 9, because here it's only the 1 that's got the power on it, not the 8, and 1 to the power of anything is just 1. 1 times 1 times 1 times 1 is 1. Okay, so I think it's going to be a calculator thing here. 8 add 18 is 20, so I've got 26 add 16 root 2 minus 8, 9, 19 equals, I think I've got 7 add 16 root 2. To be honest, I like that more as an answer, but does that match up?
It does indeed, yeah.
Yeah, so 7 add 16 root 2 is
29.627417.
Excellent. But this is obviously a much nicer answer than the decimal. And it does require you to be able to manipulate these roots. So what I did was 2 to the power of 3 over 2 means the square root of 2 cubed, which is root 2 times root 2 times root 2. And these two multiply together to make 2. So it's 2 root 2. And then I had 8 of those, which is where that 16 came from. Excellent. One more? Okay.
Right, well, it's in the nice form this time, so we don't actually need to do any sort of C1 algebra before we get to that point. So let's, what are we doing? We're integrating that one.
Yeah, normal C1 integration.
Right, okay. So no number there, x to the 4, so that's going to be 1/4. And then we've got a 3 there, 1/3 x to the 3 plus 5, 1x. That's it. C2, so we don't need a plus C, we do need our limits in. Right, so top limit is going in first. We have got, what have we got? Brain is not working today. Minus 1 to the 4 plus, that cancels, so we've just got minus 1 cubed plus 5, that's minus 1.
And then always minus, yeah. Then you put the bottom limit in.
Minus 3, 4, minus 3 plus 5.
Okay. Meanwhile, I will work out what the calculator thinks this is. So if I can do the calculator.
Yeah, I doubt it.
Minus 3, 2, minus 1. Apparently it's 16.
Whoo! Minus 3 to the power of 4, 3, 9, 27,
81.
81. 4.
Minus 27?
Minus 27. Minus 50.
Okay, so this one is 1/4 minus 6, which is minus 23 over 4, minus, then that one is 81 over 4 minus 27 minus 15 is minus 87 over 4. Excellent bracket use. Because we've got this minus minus coming in here.
Yeah.
So if you're keeping everything until right at the end, keeping them in their square brackets, then it's going to be a lot less likely to go wrong. Okay. I think well, okay, minus 23 over 4, add 87 over 4
Yep.
is 16.
Which would be, yeah,
Yay!
something everything.
Fantastic.
Brilliant.
Yeah, so what we've got going on here in C2 integration is C1, normal C1 integration. The only things that are different is there's no plus C there, and that the limits on the integral appear on the right-hand side once the integration's been completed. So that's essentially just C1. Then all you have to do is put the top limit in as your x, then minus, then put the bottom limit in as your x, and then work it out. And because your calculator will do this for you, you can definitely know that you're correct, even though there's loads of numbers involved, so it's good. So what we're actually doing here is, well, we're fiddling around and finding an answer, but what this is finding areas on curves, or areas to do with curves. So the graphs that are shown are these graphs. So this is the graph of, it's got a funny thing that happens there. And what the limits are, 4 and 6, are x values. That's why we put them in as x values. Here's x is 4 and x is 6. And we're just going up to the curve from 4 and 6 and finding this area here. That's what we're actually doing. So this one here, here's the curve drawn here, and what we're doing is going from 1 to 2, so here's 1, here's 2, bottom limit 1, top limit 2, and finding that area there. And here's the curve, the cubic curve. We started at -3, we stopped at -1, that was the top limit, and we found that area there. So this area here was 16, for example. I can't remember what the other ones were. So you might, in an exam, see the question phrased, find the integral from -1 to 2 of x squared plus 4x dx. You might see it like that. Or what you might see is the question, find this area. And you would know that you needed to use integration to find that area.